seated. The Vice Chancellor and the Chairman of this occasion, Professor Wahab, Olasupo, Egbewole, S.A.N., ably represented by the Acting Provost, College of Health Sciences, Professor Adekule Bashir Okeshimo, the University Registrar, Dr. Fola Olowoleni, the University Librarian, Dr. Kamaldeen Tunde Omapupa, the inaugural lecturer of today, Professor Jacob Olayiwola Aweda, Dean Postgraduate School, Professor Mojisola Bakari Odunola, the Dean Student Affairs, Professor Musa Toyi Yakubu, Deans of various faculties here present, the directors of various centers and units here present, distinguished professors physically and virtually present, scholars of the university here present, the staff and students of the university physically and virtually present, friends of the university physically and virtually present, distinguished members of the press, ladies and gentlemen, you are welcome to the 217th in the series of inaugural lectures of this great citadel of learning, the University of Ilorin. Distinguished ladies and gentlemen, the 217th in the series of inaugural lectures of the university has been entitled Engineering Technology and Technology of Manipulation of Process Parameters, and it is to be delivered by Professor Jacob Olayiwola Aweda, Mr. Vice Chancellor, sir, it's over to you.
We thank God for this occasion. First and foremost, I need to deliver a message from Vice Chancellor, Professor Wahab Egbewole. He was very much aware of this as the first inaugural lecture, and he wanted to be here, if not for the official assignment that took him out of the station. So his apology, and I stand in for him. The inaugural lecturer of today, please stand up for your recognition while I recite your citation. The biography of Professor Jacob Olayiwola Aka State School State and Government Ilorin. He later proceeded to Kwara State College of University from 1995 to 2007, where he bagged his Ph.D. in mechanical engineering. Institute of Agricultural Engineering, Rostov-on-Don at USSR. And I also got postgraduate from Sokoto because he started his career as an assistant lecturer at his university in 1992 and rose through the rank to become professor in 2019. His professional qualifications include the following: member of International Association of Engineers, fellow Nigeria Institution of Mechanical Engineering, Teachers Education Council of Nigeria, Council for Regulation of Engineering in Nigeria, and in addition to the above, he has a lot of administrative experiences, which I will enumerate below. He was chairman of the Accreditation Committee in 2010, acting head of Department of Metallurgical Engineering 2014, and assistant secretary, Nigeria Right of Engineers, Ilorin branch from 1997 to 2000. Professor Aweda has presented papers, international and local conferences. He has lots of international and local based publications to his credit, and is happily married and blessed with children. I present to you our inaugural lecturer. Thank you.
Thank you, Lord Jesus. The Vice Chancellor, sir, members of the University of Ilorin Governing Council, Deputy Vice Chancellors, the Registrar and the Principal Officers of the University, Provost, College of Health Sciences, Deans of other faculties, Postgraduate School and Student Affairs, particularly the Dean, Faculty of Engineering and Technology, Directors of units, professors and other members of Senate, heads of department, particularly head department of mechanical engineering, members of the academic staff of university, members of the administrative and technical staff of the university, members of the academic staff of sister universities, ministers of God here present, my lords, spiritual and temporal, traditional rulers here present, my families, nuclear extended, relations and friends, members of the Nigerian Society of Engineers here present, members of the Nigerian Institution of Mechanical Engineers here present, members of Unilorin Alumni Association, great University of Ilorin students, gentlemen of the print and electronic media, distinguished guests, ladies and gentlemen, I will be glad and rejoice in thee. I will sing praise to thy name, O thy most high. Psalm 9 verse 2. I give praise and adoration to God who has been my help, my shield, and has sustained me through my life journeys, and has granted me grace this day to deliver this inaugural lecture. I thank the Vice Chancellor, Professor Wahab Olasupo Egbewole, SAN, for the approval given to present this inaugural lecture of the University of Ilorin. God has a way of answering prayers, in that despite efforts made to have this inaugural lecture delivered earlier, all proved abortive. That Professor Wahab Olasupo Egbewole, SAN, is the chairman of today is just a divine arrangement by God. I grew up in the Okeybo-Ifetedo axis of the old western state, from where my father made frequent visits to Ile-Ife to sell his farm products, and in return biochemicals for his cocoa farm. This is also the first inaugural lecture as the first chancellor of the Better by Far University. As a secondary school student, my teacher wanted me to read medicine because of my good understanding of science subjects. For medicine, to read physics, chemistry, and biology in the then Kwara State College of Technology, School of Basic Studies. After 2 semesters of 3-semester course, I found out that there was an urge to change my course to architecture. I made an attempt to change to physics, chemistry, and geography or mathematics, but I was informed that it was not possible to register for any new subject after 2 of the 3 semesters. All efforts I made could not yield any result. I then got married to my fate. When the opportunity came for scholarship under the Bureau for External Aids, I did not hesitate to fill architecture and civil engineering as my first and second choice of disciplines, respectively. At the interview which held in Kaduna, the panelists, after asking me a few questions, offered me engineering technology, after which I was asked to respond. Just while I was still thinking of what to say, a member of the panel, possibly noting my dilemma, made an attempt to educate me on the opportunity awaiting me on my return to Nigeria if I accepted the offer. The other thing that happened to me in the quest for a career was that a few months after the said interview, the admission letter came and I was to proceed to USSR to read mechanical engineering instead of my preferred choice of architecture in Poland. Mr. Vice Chancellor, sir, this was how my journey to mechanical engineering began, with specialization in production and manufacturing engineering. And the reason for today's lecture, engineering technology and technology of manipulation of process parameters. Engineering as a profession applies scientific knowledge of mathematics, physics, chemistry, and biology, and other specialized scientific courses to the optimal usage of resources to the benefit of mankind. The engineer is involved in planning, design, fabrication, construction, operation, maintenance, manufacturing, management, research, and development, and many more. The practice of engineering is being carried out daily by everybody. The lifting of legs, lifting of arms, talking, and accomplishing any task is engineering. Thus, the mechanical engineering maxim of when it moves, it's mechanical. Engineering technology is the practical application of science and engineering to a wide range of real-world problems, which is the use of scientific principles to design and build machines, structures, and other items, including bridges, tunnels, roads, dams, vehicle, equipment, and building. The discipline of engineering encompasses a broad range of more specialized fields of engineering, each with a more specific emphasis on particular areas of applied mathematics, applied science, and types of application, as contained in current BMAX. The processes used in converting raw materials into finished products perform one or both of 2 major functions. First, they form the material into the desired shape. Second, they alter or improve the material. Forming and shaping processes are classified into 2 broad types. Those performed on the material where temperature may or may not be involved. Aweda et al. 2018a. The processing of materials in liquid form is commonly known as casting when it involves metals, glass, and ceramics. It is called molding when applied to plastics and some other non-metallic materials. Most casting and molding processes involve 4 major stages. 1, making an accurate pattern of the parts, making a mold from the pattern, introducing the liquid into the mold, and removing the solidified metal from the mold. The cast material can further be altered by additional mechanical treatments and operations. Despite additional operations, failure occurs. The failure of engineering components frequently leads to disruption in service, and when it happens, its analysis and prevention need a systematic approach of investigation to establish the important causes of the failure. Engineering component or assembly is considered to have failed under any of the following three conditions: when the component is inoperable, when it operates but doesn't perform the needed function, and when it operates but safety and reliability is not guaranteed or very poor. The failure of an engineering component in actual working conditions can occur due to a number of factors related with design, materials, manufacturing, surface conditions, processing, which is today before you to present, and many others. Aweda 2018A and B. Therefore, my work is on squeeze casting of aluminum metal. Processing, therefore, is subjecting material to a series of actions in order to achieve a particular result. This involves a complex series of chemical, thermal, and physical processes that prepare a starting material, which we call raw material, create a shape, retain that shape, and refine the structure and shape. Material processing is an integral aspect of our engineering work and design, which involves the conversion of raw materials into final applicable shapes. Processing is the procedure that is used on other products before they are made available for end users. Materials are processed to strengthen them and make them more durable and more adaptable to various situations. One versatile material processing method is squeeze casting techniques, as reported by Aweda 2007 and Aweda and Jima 2007. Casting generally is one of the manufacturing processes where solid metal is heated to melting temperature and is then poured into a prepared cavity or mold, which contains it in proper shape during the process of solidification. Aweda 2008A. It is the fastest and most practiced method of all fabrication processes for shaping metals to shape. New technology has shown that the mold could be used repeatedly without destruction, going through squeeze casting, do each casting. All the errors and failures of the previous methods of casting has been taken over by squeeze casting. Therefore, my work was on aluminum. The study of the properties of materials become important subject due to many application materials undergo widely. Most widely used metallic materials in engineering is steel, copper, aluminum, and their alloys. Steel has a wider usage than aluminum when strength is the basis of construction. The high density and crucial characteristics exhibited by steel limits its use and have made aluminum more preferable in most industrial applications. Aluminum is lightweight, coupled with a relatively high strength when alloyed, has its application in building, electrical industry, aircraft manufacturing, automobiles, aeronautics, military, and as domestic materials. When alloyed with other metals, aluminum exhibits improved mechanical properties. Increased cooling rate is one of the most influential factors affecting the product squeeze casting. Increasing the cooling rate of critical value in Aweda and Adeyemi 2007 and 2009 discovered defining effect upon grain size, gravity nodule size, and nodule count, and consequently improve the ultimate tensile strength, impact resistance, and hardness of squeeze cast aluminum material. Mr. Vice Chancellor, sir, permit me to discuss briefly my work on the various process parameters leading to the production of sound or quality casting of aluminum products. Can you show figure 3? Figure 3. So as is being shown, figure 3 is a schematic diagram of where we have 10 places where we monitor the temperature of the cast. 2, 3 within the cast metal, 6 within the mold, and 2 by the interface. That is, when you pour your multimeter, there is that interface between the multimeter and the container. So what happens at that surface determines what the quality of your product. And all other processes will just come along with it so that your quality product will be produced. So you have met quality, gross, and any other grit that is pertaining to it. Multi-metal superheat in this situation does not need to be very high. It depends on the position of your mold and your foundry, and that superheat damage to either the mold or your cast. Then the pressure applied, the pressure level. So they can't show this. So now this is what we are saying. Just hold on. You will see these blades that are, this one of the mistakes that we make in the previous casting, and that by the time you use squeeze casting, most of those things are eliminated. And the pressure applied are between 30 and 108. I will just quickly use it to take the parameters, and then the press speed and lubrication. So temperature is important here. Yes, this is it. So all those black dots are the positions at which and numerically, and you can see the punch goes down, and that there are 10 of those positions, and that what happens between the die and the when you bring out aluminum, you buy aluminum, you see leakages. This is what we are saying, and that in some household, those figures, please, the photo, you see the leakages. Yes, media is having some challenges. Figure 5. First, control parameters will eliminate the effects of electrical conductivity. Using all these variable parameters, we discover that it conducts electricity very well. Aluminium is used as electric overhead cable, but cannot use as aluminium. You cannot use copper as overhead for the weight. So today, aluminum find this not only in the kitchen, in the pot, you find it almost everywhere where building, structures, aeronautics, in every other place. And that is what we have done with squeeze casting. We improved the properties, and it can be, and to have in the market very good and quality inputs, including pots. Initially, for the automotive industry, using aluminum as base metal, while egg, C, and snail shells as, please, figure 6. Composite, Aweda, Olawole 2020A. But as the work progressed, Dr. Iqbal Farasat of Interdisciplinary Research Center in Biomedical Materials, Comsat University, Islamabad, Lahore in Pakistan, through the methodology of the preliminary result obtained and having the facility to conduct laboratory works on high-apatite material, accepted to be part of the research work. He accepted my Ph.D. student, Dr. Olawole M.Y, to work with him on zinc and magnesium using because of the calcium content they possess. The research was carried out under the World Academy of Sciences, where hydroxyapatite material method. Hydroxyapatite, a biomedical material, is used as bone substitute implant in lieu of allograft implant of material. Olawole Aweda 2019. Applying, the shells were turned into powdered form. We have zinc and some of these things, when you go to the sea, sure, you find them everywhere as waste, and even the eggs. So we discovered that this material possesses calcium and can be reprocessed. And some of us who are carrying one thing or the other in the body, implants, this can be alloyed together with zinc and magnesium because of the biocompatibility. The shells were turned into powdered to form zinc magnesium alloy composite. The developed hydroxyapatite material was subjected to mechanical and biomedical tests. The composite obtained became lighter in weight with increased compressive strength, elastic modulus, and micro. The in vitro degradation was determined in simulated body fluid. The result showed improved properties when compared with the existing of the powder addition into zinc, magnesium. Appeared our own with the already made with the one already in the market, commercially one, and we discovered that it is very, very compatible. So many of us are now carrying implants, and some of these products are alloy of what we call waste materials that can be converted to useful waste. The Vice Chancellor, sir, other research efforts in the area of laboratory equipment. There were further by developing equipment in the area of engineering technology. The use of this laboratory equipment was informed by the difficulty faced with the engineering laboratories with up-to-date facility required for teaching that will meet the global trend in innovation and technology, and particularly the current outcome-based evaluation objectives. The role of laboratory equipment include every opportunity to learn about science through hands-on experience that enrich learning and improve thinking skills. Some of these we have, please, figure 19. So we have this one that is called germinal end quenching test apparatus or hardenability test. It is there in block 7, and this one can be used to measure the hardenability. We have creep measuring apparatus for both compression and tension of materials. is the tendency of solid material to move slowly or deform permanently under the influence of persistent mechanical stresses. Creep is sometimes referred to as silent killer, as its occurrence is as a result of long-term exposure of material to high levels of stress that are still below the yield strength for such material without warning. Please, can you show figure 20? So you can measure this one is also in the lab in compression and in tensile. Family, Baba Joshua Adeleke and family, Dr. Femi Abiodun family, Mr. Kole Ajibade, Dr. Yemi Akande, Professor Rotimi Omotoye, Professor Noah Yusuf is a friend, just put in here. So it's a special guest, it's a close member of the Aweda family. Thank you very much, Professor Noah Yusuf. Professor A.A. Adeoye, thank you very much. Professor R.Eng,